Hello, my name is Khaled Alrantisi and I'm a computer science student at Arato International University. This is my submission for Agentic Garage Assistant project. I built a question answering assistant over a small knowledge base from my own diploma thesis on DOS attack detection using autoencoder, like basic Garage, which retrieves the same way for every questions. My agent makes three real decisions about how to retrieve, and I'm going to show each one actually changing the outcome, not just sitting there as and use it good. So the first thing we'll do is I will open the PowerShell and I will move into my project folder. Which is called Khaled Alrantisi, Agentic Raj, and we are now into my project folder. Then we will go to, then we will install what the project needs. Okay, require. Okay, so this installs what the project needs, mainly scikit-learn, which powers the search, and NLTK, which I use for word streaming. And we will build now the search index from my knowledge, which is cd source. Okay, Python, just Now, this builds the search index from my knowledge base, which is 20 chunks taken directly from my thesis. So it will show here that I indexed 20 chunks using backend TF-IDF. So now we'll write Python agent I. Okay, now the assistant is running and ready to answer questions. So we'll just write, for example, hi. It will say, ask me something about my thesis project, which is DOS detection. And if I want to write, for example, what is 45 plus 12? It will say 57. And what I go to see the model achieve. It says here, based on the knowledge base, the final model achieved an accuracy of 93.45. And the first decision here is routing. You can look at the trace after each question. Treating skips the search completely. A math question goes straight to the calculator instead of the knowledge base. And the only real question about my thesis actually triggers a search with the answer grounded in a specific source chunk. So now we'll try to write two questions. What data set was used and what was the F1 score? This is actually two separate questions. If I searched it as one, both answers would come back quicker. Look at the trace here, you can see it's split into two independent search. It merges the results before answering. Now we'll try with the third question is what are the downsides. So this is the clearest proof that the decision generally changes the outcome, which trace. The first search score 0.0, it fails. The agent rewrites the question, search again. The score jumped to 0.164 without this retry step. This question would have been wrongly refused. if we write, for example, here, what is the capital of France? See, the knowledge base doesn't cover this. It says the same retry process is runs here too, but it still fails both times. Instead of guessing, the agent honestly tells me that it doesn't know. So what makes every other answer trustworthy. So while testing this, I actually found a real bug. My search engine treated the words limitation and limitations as two completely different words. So I correctly written question still failed. I found it by calling the search function directly with smaller and smaller queries until I isolated the exact word that was mismatching, and I fixed it by adding a stemming algorithm, and it's fully documented in my readme file here. So this one is fully documented, and it is also in GitHub. You can find it. I will put the link in the description below. And my stack is TF-IDF with stemming for search, NumPy as vector store, and pluggable connection to Groq or Gemini free tier APIs, or the offline mode that I'm demoing right now, which needs zero setup. So all the code and readme and both file cases are here on my GitHub repo. And thank you for watching. I hope you understand what I said. Thank you.